Hello everyone and welcome to this Cisco Community Live event. Today we are going to talk about all things LTE, 4G, 5G and whatever's next. So here you will have the opportunity to learn more about these cellular technologies and how they are fitting in today's networks. My name is Hilda Arteaga and I am a community manager of the Cisco Community and the host of today's event. So before we start, I would like to let you know that the Cisco Community is actually an online forum with over 500,000 members where you can get an answer to your technical questions prior to opening cases with the tag. That means that you can either answer or make questions and contribute with different experts all around the globe with documents, videos, and blogs. So thank you so much for joining us today. Before we start, what I would like to share with you is something about the news and upcoming and related events that can help you all to learn more about this. So first of all, I would like to start with this Ask Me Anything connected to this session. What's this about? This is an Ask Me Anything form connected to this session, and the way we use it is just in case you have further questions regarding this event or regards everything that David is going to present today, you can ask them on this session and this forum. Or let's say that we have a question from you and we need some time to validate information, you will be able to find it here. This form is going to be open till Friday, November the 10th, that is next week. So remember, you have further questions, we don't have the chance perhaps to answer to your question today, or you need something extra, you will be able to find it on this session. Also, for those of you who would like to know more about the new Catalyst 8000 series that Cisco is launching, we are going to have a deep dive just in next week, so you will have a look there. It's going to be with Sumad Mali at the same time, 10 a.m. Pacific. So if you are interested in learning more about this, please feel free to join to this event. Remember that all the information that I'm sharing with you and everything that I'm commenting, you will be able to find it on the right side panel of this screen. Also, we would like to invite you to become an event top contributor. That means that please help us to contribute in the community, and we recognize everybody who's helping out to answer questions, who's hosting events like these ones, who is assisting people or publicating things. So you are more than welcome to come here and receive an award from the Cisco community. Also, please help us to rate the content that you can see in the community. That helps us not only to recognize the high quality content that we find on the community, but also to say thank you to people who have been helping others. Let's say that you make a question in the community on the forum and someone gives you an answer and you find that information is useful, you can give him a helpful vote or her as well, just by clicking on that star that you can see on the screen. Also, they give you the right answer, you can accept that as a solution, and that will help out a lot in the way of identifying future results. That is that in future, if you have a similar question, when you look for it, you will find already that it has the right answer. So let's get started with today. I would like to introduce you to the panel that we have, and I would like to start with the presenter who is going to guide us through all these cellular technologies. His name is David Roten. So David is a technical marketing engineer with Cisco's enterprise routing BU team for the past 7 years. He has been in his current TME role with the enterprise BU for this time. During all this time, he has spoken at several Cisco Live events, along with training and customer events globally. Prior to that, he spent a number of years working as a dev test engineer, covering SIP 6000, SIP 4000, and SIP 200. 600, 400, and 200 line cards on the 7600 platform. Hi, David, and welcome, and thank you for joining us today.
Thank you.
Also, we'd like to share with you that Kevin Gomez, we have Kevin Gomez, who is going to be helping us out to covering all the incoming questions in the meantime that David is presenting. Kevin is a product manager and a member of the Enterprise Routing Product Management team. He currently focuses on cellular portfolio, Catalyst Cellular Gateway 5 and 5G portfolio. He holds a bachelor's degree in science in computational mathematics from San Jose State University and an Amazon Web Services Cloud Practitioner certification. Hi, Kevin, and thank you so much for joining us today.
Hi, happy to answer any questions as they come in.
Awesome, thank you. And well, also, if you would like to have a deeper look on everything that we are going to comment today and what David is pointing out, you will be able to have a look and a deeper dive into these presentations and the slides on this page. They will be available just right now in a moment and in the Cisco community. Remember, if you find that helpful, just give it a helpful vote. And also, don't forget that you are able to submit your questions. Please help us out to submit them in the Q&A panel that's located on the right side of your screen, or on the tiny spheres that you have if you're on a mobile device, such as an iPad or a mobile phone. And please use the chat if you have some issues related to your connection to the audio, or if you would like to connect to someone with us in particular. And well, that just gives me the chance to pass in the microphone and the presenters both to David. So please, you can start sharing with us.
Sure. Just give me one moment. Okay, thank you very much. So let's go ahead and get started. Good day, everyone, and welcome to the session today. LTE, 4G, 5G, and whatever is next. So just to set the level for what we're going to be talking about in today's session, we're going to be talking about enterprise routing role in LTE networking. So the enterprise routing BU is focused on building devices which act as clients for wireless WAN networks. So this includes the ISR1000, ISR1000, Catalyst 8300, and the ISR 900 routers that today can attach to wireless WAN networks as clients. And they can also provide Wi-Fi AP services to wireless LAN networks. So in this presentation, we're going to focus on these client technologies and the use cases associated with those. There are other Cisco business units that focus on building the infrastructure to enable wireless WAN core networks to actually provide the 5G infrastructure to deliver 5G services to other clients. That's not where we're going to be focused today. We're going to be focusing on taking advantage of 5G networks that are provided by service providers or enterprises, and we're going to be looking at the client side of that. So the agenda for what we're going to be going over is talking about 4G and 5G cellular technology, looking about how 5G cellular integrates with Wi-Fi 6, and then moving on to some use cases for 4G and 5G, and then talking about the current enterprise hardware offerings in the LTE space, and then a quick review of some of the antennas that we have in the LTE space. So, but to start out with, I did want to ask a question of the folks that are on the call. So what is your experience with 5G networks so far? We have 4 different responses here, and I think we're going to give everyone about a minute to respond to that. But first option is none, you're new to 5G and you're here to learn. Or maybe you've got 5G on your mobile phone in the city where you are and you're eager to learn more. Or you've actually started to deploy some 5G networks in your enterprise, or to look into that. Or maybe you've actually had your hands on some 5G equipment for enterprise networks to be able to deploy that. So if you would submit your answer, and then we'll review those and take a look in just a few seconds. Okay, so it looks like from surveying the audience that most folks that we're talking to, 14 out of 51 folks that are on the call don't have any experience here with 5G networks, and you're here to learn, and that's great. We're going to be starting with some foundational items to talk about in the 5G space about how you can take advantage of 5G networks as well as how they integrate with cellular, so you're in the right place for that. So what are all these different cellular technologies that we have? There's a ginormous vocabulary out here for LTE and cellular networks. You know, the numbers range from 2G, 2.5G, all the way down to 5GE, 5G, and then there's Wi-Fi 6 that sort of comes in the mix with that. If you look at older technologies like 2G, there's going to be acronyms like GSM, GPRS, and EDGE. You know, when you move to 3G, then you start talking about UMTS and CDMA 2000. Do you really need to know about all these things, and you know, and how deep do you need to dig into that? And the good thing to say about this is that we've moved forward from a lot of these sort of disparate technologies as the cellular networks have matured and we've moved into the 4G and 5G spaces. A lot of things have become much more standardized, and so you don't have different types of networks running in North America that you have running in Europe or you have running in Asia. But with 4G LTE, things consolidated significantly so that we ended up with being able to look at 4G LTE Advanced, and then LTE Advanced Pro. And in the 5G space, we're looking at 5G Sub-6 and then 5G millimeter wave, where 5G Sub-6 and millimeter wave refer to the different RF spectrum that we're talking about that those networks accessing. In the past, with 4G networks, we were primarily talking about a WAN technology. And then with 5G, we're starting to sort of blur the lines now a little bit between a WAN and a LAN technology with 5G, whereas Wi-Fi 6 is still solidly in the LAN space. But as we've moved away from all of these terms that we had in the 2G and 3G space, now we've got 5G, which is now sort of stepping into both the LAN and the WAN side. And so we're going to try to pick apart some of those behaviors and use cases as part of this presentation. For the 4G and 5G vocabulary as we've moved forward, back in 2011 was whenever we had the advent of LTE. And so there's an organizational body, 3GPP, that releases certain standards that define what LTE is. And so as they do that, there are different categories of LTE devices that we have that are deployed. And so whenever we talk about these different categories, a lot of that defines the connection mechanisms, the protocols that they use, as well as the speeds that are available. So in Cisco world, the initial release that we had for our LTE hardware was Category 4 devices, and that was back in 2011. And those Category 4 devices were defined by 3GPP Release 8 and supported bandwidths that were 150 megabits per second downstream and 50 megabits per second upstream. As we moved a little bit forward, we came to LTE 4G Advanced, and that's what we called Category 6. And that was defined by 3GPP releases 10, 11, and 12. And then it covered various categories, 6, 11, and 12. But for Cisco devices, we focused on Category 6 devices. And those had bandwidths from around 300 megabits per second downstream to 50 to 51 megabits per second upstream. The current level of devices that we offer are Category 18 devices. And this is known as LTE Advanced Pro. Or you might also have seen that called 5GE. And those Category 18 devices came around in 2018, support downstream of up to 1.2 gigabits per second, and upstream up to 200 megabits per second. And so now we're just on the cusp of moving forward to 5G devices, which are just around the corner, and they're going to support bandwidths starting at 6.5 gigabits per second downstream from the cellular network. And so it's a huge leap moving forward from LTE Advanced Pro to 5G. And in that 5G space, we're no longer looking at just the WAN technology, we're opening it up to LAN opportunities as well. And we'll talk a little bit about how that's actually going to be implemented by the 5G networks. So all these StarG technologies are supposed to be WAN technologies, right? Well, sort of. They always have been traditionally up until this point. So Wi-Fi 6 is clearly a wireless LAN technology. We're all familiar with Wi-Fi. And then up until this point, 4G has always been a wireless WAN technology that was implemented by service providers using a licensed frequency space. And that infrastructure that was associated with that was non-trivial, and it's expensive. It had this licensed frequency space that had to be purchased from the authorization to use it, purchased from government entities. And so it wasn't something that someone could just walk up to and implement all by themselves at a low cost. Moving forward, when we go into the 5G space, it can be used as a wireless WAN technology, just like 4G has, and it can be implemented by service providers using licensed and unlicensed frequency space. There's a frequency space called CBRS, or Citizens Band Radio Spectrum, and there's some of that radio spectrum in the millimeter space as well as the sub-6 space, millimeter being at a much higher frequency than the sub-6. And so service providers as well as enterprises will be able to use 5G to deploy networks. And enterprises are going to be very interested in that unlicensed frequency space. There's no cost associated with paying a government entity to use that. And you'll be able to implement networks that use 5G technologies that are localized to smaller areas with much smaller cells so that an enterprise can take advantage of a LAN, of 5G as a LAN technology without having the expense of having to do it, to pay a service provider to come in and deploy those networks in congested small spaces where they might not have a great deal of interest in doing that, but an enterprise would be able to do that and then marry that 5G LAN technology with Wi-Fi 6 so that they complement each other based on the type of areas that they're trying to serve. So how does 5G actually improve on 4G? 5G has much, much lower latencies, an order of magnitude in reduction for the latency associated with 4G. So 4G, you're looking at latencies of 30 to 50 milliseconds. With 5G, you're looking at latencies less than 10 milliseconds, typically for connections. So the responsiveness of that 5G network is going to be much, much better than what we had on previous 4G LTE technologies. Higher speeds are available to us. 4G networks tapped out at about 1 gigs for downstream, and 5G networks are going to be 5+ gigabits per second downstream. So, we're quickly going to be looking at perhaps even a level of magnitude increase in the downstream speed available to us in a 5G network. 5G networks also are going to support much higher density networks as well. More subscribers supported by cells in a single cell, as well as being able to deploy more cells in a localized environment. That gives you the ability to have very high, dense, supported areas such as, say, a stadium environment where you have tens of thousands of subscribers that are localized in an area no bigger than a few football fields. And so being able to deploy 5G networks in a space like that gives you very high bandwidth, responsive networks to a huge number of subscribers all in a single network. And so you also get less degradation of performance with that higher user density as well, whereas 4G networks are going to suffer whenever you add many, many users. 5G networks are going to be much more tolerant of that. So the other things that are improved on in the 5G versus the 4G space is the expansion of the supported radio frequencies that we have. Traditional frequency space for 4G LTE networks is all in the sub-6 space, and that overlaps, of course, with the 4G LTE frequencies that we have today. And we have availability for the CBRS, or the Citizens Broadband Radio Service, which is that unregulated band called N48, which ranges from 3.55 to 3.7 gigahertz. And in the U.S., that's an unregulated space, and that's where the LAN opportunities come in. And in that unregulated space, an enterprise can easily come in and offer services in a small cell environment using that CBRS radio space and be able to give LTE services to their local enterprise. And then moving forward, because we see sub-6 networks as being what's going to be deployed initially, we move forward into the millimeter space from 24 gigahertz to 28 gigahertz, and then future expansion beyond that. That gives us the ability to have networks that are localized within a building so that you can offer LTE services and actually take advantage of the fact that those millimeter waves may not penetrate a building infrastructure very well, and so that the LTE service can be contained within a structure. You have good coverage within that facility and be able to offer that to customers within the space, but not necessarily have that radio frequency go beyond the building so that other entities could take up on that LTE space, and it prevents pollution of that radio space for maybe an adjacent enterprise that wants to do an adjacent millimeter wave deployment, that those are going to be isolated from each other. So what can we accomplish with each one of these frequency spaces? So typically what we have today for LTE radios is what's in the sub-3 gigahertz space. And that frequency range goes from about 700 to 2.6 gigahertz. And it's good at penetrating a building at under 2 gigahertz. This is why you can be inside a building somewhere and get decent LTE signal inside the building for the most part, unless you're in a building that's mostly metal where it turns into a giant Faraday cage for you. But if you're in a wooden structure or in a home, you're going to be able to get decent sub-3 gigahertz LTE service, inside of a building. If we move forward to the CBRS space, which is higher at that 3.5 to 3.7 space, the building penetration is limited, but it's still workable, and you're going to be able to get bandwidth still ranging up to around 300 megabits per second, which is serviceable for quite a few applications. And then if we move forward to that millimeter wave space that's going to be looked at for 5G, the building penetration is very poor. But look at the download and upload speeds that we're going to be capable of taking advantage of, up to 10 gigs potentially, with the first generation of 5G technology. So whenever enterprises deploy this, the millimeter wave is going to be very attractive for indoor applications where you want to isolate that. But if they want to deploy services that are of a broader scope, perhaps that are in an outdoor space where you don't have line-of-sight access to the antenna for millimeter wave, then CBRS would be a good choice for that because it's unregulated, and that they would have the ability to perhaps have some building penetration, some services that are out in the field. And you'll see the other items that are in this field or in this table that are in green, these ISM fields, those are the radio frequencies that are used for Wi-Fi. And you'll see how the 2.4 gigahertz Wi-Fi, again, has decent building penetration but not great. So it relates more back to that sub-3 gigahertz LTE space, whereas the 5 gigahertz Wi-Fi relates closer to what you have to the CBRS and items above that, where you don't get great 5G signal penetrating walls and surfaces inside commercial buildings or even within residential buildings as well. And so that 2.4 does a much better job of moving through spaces than the 5G does. So 5G and millimeter wave are much better for line of sight or open space type applications. So sort of how have the technologies been mainstreamed over time? So up on the Wi-Fi 6 we have above, initial AP started to roll out between 2018 and 2016, and then we had limited client that were available in 2019. And then after that, we've had full-featured APs, and then at this point in 2020, Wi-Fi 6 access points are commonplace, along with clients that can take advantage of Wi-Fi 6. And those deployments for cellular networks, or for the Wi-Fi networks, are relatively simple. There's no regulations that are involved. Typically, you can just deploy the hardware. There's no buying of spectrum space. And to deploy and manage those systems is fairly simple in comparison to what it is required to deploy cellular networks, because in a cellular network, there's a much higher deployment cost, startup cost with higher physical and logical complexity, because there's multiple moving parts to those LTE networks that live behind, and there's a lot more regulation in that space. And so that's why you'll see here that the 5G WAN deployment time frame is much more spread out than what you had for Wi-Fi 6. Wi-Fi 6, you had basically within a period of a couple of years, you went from having the initial APs to having clients that are commonplace that can take advantage of those. Whereas with 5G WAN technology, the first test deployments happened in 2018, and you're going to be looking all the way out at past 2022 before there's going to be bulk rollouts globally of 5G technology in that WAN space. And so it's about twice the amount of time that it takes to roll out that 5G technology. The same thing is going to be the case for 5G as a LAN technology, where we have those 5G networks that are localized to an enterprise as opposed to a service provider. It's a little bit more compressed because we've already had the 5G start as a WAN technology. So we're looking at 2019 moving forward to sometime after 2022, where you have millimeter 5G LAN that's commonplace, but you're still looking at a span of 3 to 3.5 years to get that 5G as a LAN technology. So Wi-Fi 6 is going to be out there first. It's going to be more established and more easily deployed, but 5G as a LAN is going to give us many, many opportunities that weren't necessarily available to us in that Wi-Fi 6 space. It's just a matter of getting to where those networks are a little bit more ubiquitous. So how does 5G cellular fit in with Wi-Fi 6? They seem to sort of overlap in that LAN space. So Wi-Fi 6 and 5G are complementary technologies, and they overlap in that LAN space, not so much in the WAN space. You're not going to use Wi-Fi as a WAN technology, but in that LAN space, they do overlap. And Cisco is invested in both of those technologies. We have commitments in both of those technologies on the offering as well as the client side, and you're going to see that going forward. We partner with leading device and service providers for both technologies so that we can offer a tremendous amount of value and integration into a single solution stack using Cisco's DNA offering. And as we see the technology moving forward, we're basically going to see Wi-Fi 6 will remain the favorite technology simply because of the lack of regulation as well as the ease of deployment. But 5G will be the focus for wireless WAN connectivity moving forward over time, and then we'll start to infiltrate in interior spaces as that millimeter wave technology matures and we get more of that hardware available. Then we're going to see that start to overlap more with Wi-Fi 6 and become not so much of a competition as complementary to Wi-Fi 6, so that you have offering of both, and you have devices that are going to be intelligent enough to be able to automatically switch between a Wi-Fi 6 connection and a millimeter wave connection depending on the circumstances of the environment they're in and where they have the best signal and those sort of things. So in a 5G Wi-Fi 6 versus the LAN today, complementary technologies, service provider versus enterprise. In the future, we're going to see those integrated where enterprises are going to be offering both. Today, you're in a world where service providers offer LTE 5G services and enterprise offers a WAN service to their employees or to their customers. In the future, you're going to see those basically where enterprise and service provider offer both of those, particularly on the enterprise side as you start to see the LTE start to infiltrate more into the enterprise side. Typically, Wi-Fi 6 is going to be deployed in what we would call carpeted spaces, offices, restaurants, places of business where they want to offer internet access to their customers. Wi-Fi 6 is going to be perfectly scalable enough and easy to deploy to cover those sort of things. For 5G and 4G CBRS, uncarpeted spaces are going to be where customers take advantage of those sort of things. Think of stadium venues where you have a huge concentration of spectators watching a sporting event where the loads on those networks can be tremendous based on the events that are going on, whether it's a concert, a sporting event where people are on social media sharing their experiences at that particular event. The loads can be very high and the density is tremendous. And so 5G is going to excel in servicing those type of venues. And then you have the things that are sort of in the middle, outdoor industrial areas where you may not have a density of individuals, but you may have a tremendous density of IoT devices that are monitoring various items throughout that industrial complex. So think of for example, an oil refinery where you have many, many, many items that are in an external exposed space that need to be monitored, that you may want to have redundant mechanisms to monitor those. There may be a wired infrastructure to monitor all those devices, but you could also appreciate a 5G network, Internet of Things, where those same set of sensors can have a redundant connection to report back information from those, and the cost to deploy that would be minimal because you don't have that infrastructure to build inside that complicated industrial space. And so that would be something where you get a little bit of overlap between both of those. So just a general 4G to 5G comparison on the technologies and the feature sets that we have. In general, the cost for 4G and 5G is going to be higher than what you have for Wi-Fi. Wi-Fi is by far simpler and easier to deploy. The environment, 4G and 5G is generally outdoors, with millimeter wave 5G indoors is going to become much more common, whereas Wi-Fi is a generally indoors mechanism, although you can support it outdoors, but LTE is generally serviced better in those spaces. The complexity for 4G and 5G networks is higher. There's no doubt about it. It's a more complex technology to deploy than Wi-Fi. And so there's going to be a learning curve for enterprise entities that want to deploy 5G networks as part of that. Now, as far as the robustness goes of the network, 5G gives us an excellent set of differentiation. We have a feature called slicing. And slicing actually gives service providers and enterprises that are offering 5G services the ability to compartmentalize their offerings in a virtualized fashion such that changes that they make in that one virtualized instance does not impact other virtualized instances. So, for example, if you have a scenario where an enterprise offers customers to their manufacturing arm versus their sort of corporate arm, those networks could be sliced apart so that the corporate entity gets all the services that they need, but actions happening in that corporate side don't affect the manufacturing floor, where they have a different slice that services all the IoT devices that are out on the manufacturing floor. And that differentiation that we have in the 4G network is there via APNs, but the differentiation is not nearly as good as that you have in the 5G space. 5G gives you the ability to do a very good isolation of impact when it comes to those virtualized instances, whereas the 4G network, you're still operating on a common infrastructure. You get privacy and sort of a VPN type effect with APNs, but the underlying infrastructure is still shared in common amongst those, and so you can have cross-impact between those entities. And as far as the licensing goes, with these technologies, Wi-Fi, of course, unlicensed, easy to deal with. 4G and 5G give us licensed and unlicensed spaces to work with. 5G being able to take advantage of that high millimeter wave space as well, which has licensed and unlicensed, as well as the CBRS that lives underneath. So 5G does give you a broader spectrum in that regard. So what are some of the use cases that we have for these networks? So for enterprise networking, you're going to have enhanced mobile broadband, and this is typically what we think of with a service provider offering whenever you have your cell phone attached to AT&T or Verizon or T-Mobile or whatever company that may be. Very fast access in high-density environments, being able to do 4K video, virtual reality, 3D enhanced video. That's the first use case that most folks think of when they think of 5G LTE technologies. The next one that sort of comes into play is a fixed wireline access, which gives us the ability to have very fast internet access without having to have an underlying copper or fiber infrastructure that's put into the ground. With 5G, with having access speeds up to multiple gigabits per second, it's a low-cost alternative to that wireline broadband. It's quick and easy to deploy, even in challenging environments where you might have diverse terrain instead of just having, a flat environment. If you have a mountainous environment, being able to deploy those antennas at a high elevation, having them point down to homes or businesses that are lower than those antennas, gives you a really quick way to be able to deploy without having to invest in that wired infrastructure. And then beyond that, being able to offer critical services in smart cities with IoT deployments that take advantage of a 5G network with high reliability, low latency, and very high density as well. You heard a lot about SD-WAN from the enterprise networking group. And so there are clearly some use cases where being able to take advantage of 5G networks and that fast access for wireline access come into play. And so that's very simple here, where you have wired access, you deploy cellular access along with that, where it's an active-active scenario or even an active backup, which is typically what you see today. But with the speeds that are coming along with 5G, you're going to see that turn into more of an active-active case. And equally, you may see scenarios where you can get deployments with SD-WAN where instead of having any wired access, you just have access via two different cellular providers, so that you have diversity in case one of those goes down, but you don't depend on any wired infrastructure whatsoever. In a further redundant case, you can have scenarios where instead of having a single SD router that's at a particular location, you can add in two SD-WAN routers, each of those serviced by a single cellular connection, which gives you a level of hardware redundancy in those locations, or more high availability based on the hardware than you have when you have two providers attached to a single router. Some of the other use cases that you see here is basically where you have a single tenant with classic IP routing. So this is outside of the SD-WAN space. But in this classic IP routing, we basically have an LTE service that's enabled by a service provider. They provide a PMIP or a NEMO tunnel that traverses their network, and that gives the corporate entities the ability to manage their own address space at the branches. They have mobility for clients to move between those locations with the functionality of NEMO and PMIP tunnels, giving the ability for those addresses to have mobility. But then you have the corporate network that lives on top of that with differentiation with VRFs and BGP for routing to be able to offer services and users and general internet access from those locations across this design. And it gives you the ability for the customer to do their own encryption. They can do Get VPN, or they can do targeted tunnels that are possible as well. So this sort of deployment is very flexible, but it requires a little bit more management from the enterprises in order to bring something like this up. If we move forward to using SD-WAN technology over a single tenant, those customers are still going to be able to partition their networks. You may have different corporate branch devices that are in different categories, HR versus finance versus commercial sales offerings, and in that SD-WAN network, be able to move traffic across a custom APN or a DDN, which is the equivalent for a 5G network. So you can have different differentiation of traffic across the service provider network so that there is isolation of traffic on their network. And above and beyond that, the SD-WAN network will bring up their own tunnels as well to differentiate traffic for the different entities in the enterprise identified as A and B here. So the customer can use VXLAN, secure group tags, VRFs, VPNs to partition traffic, as well as having the traffic partitioned in the service provider network as well. And so all of the expected SD-WAN feature functionality that we offer across wired networks today, we offer across LTE networks as well. There's no differentiation that we have or no limitations we have across those LTE networks for what you can accomplish for security, data isolation across these LTE networks that you would have across a wired infrastructure. The stadium venue case, I think, is one of the best examples of a 5G network. In that stadium venue, you may have a ton of IoT devices that are in the facility to monitor environmental systems, to monitor security cameras, all of those sort of things. You have vendors that are in the facility that need to have point of sale, that need to have video services. And then you also have public devices that come in as spectators come in to watch the soccer game or the football game or whatever that event may be. And so all of those devices can attach via 5G LTE using a CBRS or a private radio space that's unlicensed. They all can attach to that cellular network. Traffic goes across that LTE packet core that lives within that stadium. And then traffic can leave that LTE core for the wireless connectivity piece and then be sent to other stadium services that are isolated for vendor and facility, stadium services for attendees, and then general internet access as well. So this gives you the ability to have the high density of devices with a full stadium and with high bandwidth needs. 5G gives us all the necessary bandwidth that we would need in order to support all those spectators as well as all those vendors that may be using high bandwidth streams. And all that's on an unlicensed spectrum. And because they can take advantage of millimeter wave, it's all going to be localized in that environment. A stadium is a huge amount of open space. So if you have millimeter wave antennas that are in that open space, they basically have line of sight to almost every spectator in that facility. So they can take advantage of the high bandwidths that are available in that radio space. And then for spaces that are more confined, they can use the sub-6 frequency range for environments that are on the perimeter of the stadium where you may not have line of sight access and things that are buried down within the building. Then Wi-Fi may become more appropriate in that aspect as well. So this stadium venue is a great use case to demonstrate all the advantages that 5G can offer. Public safety and governmental access is another thing where we can excel. So in a public safety environment, we need to have access that's available to us all the time, and we need to be able to have a network that's available to us even in times of crisis. And we've got the tools that are built in to make that happen. There may be IoT devices that are spread throughout the city. We've got public works, folks who may be out with LTE handhelds, folks checking water meters, folks who are working on traffic control systems. And then you may have public safety vehicles that are out there, so ambulances, fire trucks. And in this infrastructure that we have, we can take advantage on Cisco's LTE hardware band 14, which is dedicated or reserved for emergency services in times of crisis. And so that band 14 designation in times of crisis can be switched over so that only public safety entities have access to that band and other users are kicked off of that. And so with the Cisco LTE hardware, we support that band 14 functionality. But regardless, we have all these devices that are part of a public network. That traffic can move across an LTE core, whether it's 4G or 5G, and then we can differentiate that and park that back out into different isolated sets of infrastructure back on the other side. All the LTE devices do support dual SIMs, or almost all of our LTE devices support dual SIMs. And so that gives us the ability to basically take advantage of multiple service providers. If there was a problem with a particular service provider in a time of crisis, they could switch over to an alternate service provider as well. And then using the 5G slices, we have the ability to differentiate these services so that if there was a time of crisis, then any problems that may happen on the public infrastructure, the load, or any issues that are associated with that would not trickle over and invade into the slice that's dedicated to public safety. And so that would be isolated, would continue to function well in that sort of environment. So 5G goes very well towards that public safety type of deployment. So the next question that I wanted to ask for folks is, which use case speaks more to what you're looking for? Do you want to have a service provider, you just want to take advantage of a service provider's 5G network? Do you want to deploy a 5G network for your enterprise for just your internal use? Or would you perhaps be interested in deploying a 5G network that was for use by others outside of your company? You know, I would say a quarter of folks are wanting to take advantage of what a service provider might offer from a 5G network. And then an equal number of folks want to take it, maybe deploy a 5G network either for an internal enterprise or they want to offer that to other customers. And then there's some other folks who are out there. The majority of the folks, I think, who are just sort of trying to want to learn about this 5G networking and what it's going to be able to deliver. So this goes to show that, you know, while we hear a lot about 5G, there are still a lot of folks who are still trying to figure out what 5G can do for them. And so that's why you're here. Okay, let's go ahead and move on. So let's talk about the current hardware offerings from Cisco to see what we're able to offer you in the LTE space. So as I mentioned before, currently we offer 3 different categories of LTE hardware in the 4G space. There's the basic LTE, Category 4, Category 6, LTE Advanced, and then Category 18, LTE Advanced Pro. And so those different downstream bandwidths that you see there, 150, 300, and basically 1.2 gigs, are what we're able to offer on our current hardware. And then the 5G stuff is right around the corner, and we'll talk a little bit about what you can expect to see in the 5G space coming up. So in our current platforms, we offer embedded LTE in some of the ISR1000s, ISR 900s, as well as the V-Edge 100 platform from the Viptela acquisition that we had a little while back. Those ISR 1000s are supported in Cisco SD-WAN along with the V-Edge 100 hardware, and the ISR 1000s do support built-in 802.11ac Wi-Fi. And then they have embedded Cat6 in some of the platforms, and then we also offer the ability to add a PIM module for a second LTE radio or as a single LTE radio, but at a level beyond the Category 6. And I'll go through that in detail a little bit later. The ISR 900 and the V-Edge 100 platform offer embedded Cat4 LTE options. In addition to the embedded platforms, we do have the ability to add modules into some of the platform families to add LTE functionality to those platforms. The ISR 4000 series, we can add NIM modules that support Category 4 and Category 6 LTE. And then those platforms also support various WAN modules, voice modules, compute, UCSC modules, built-in switch modules. Very, very flexible platform that we have there on the ISR 4000s. The recent announcement of the Catalyst 8300 platform takes the ISR 4000 platforms to the next level, being SD-WAN ready in a much more robust way. And so we have the ability to put modules into those platforms as well. The ISR 1000 platform, SD-WAN supported. We mentioned before we have the PIM modules as well as some built-in options. And then on the right-hand side, you see a quick snapshot of the different NIM modules and PIM modules that we have, and I'll go through those a bit more in detail. This is just sort of an eye chart to see everything in one spot. And then lastly, we have the Cisco Wireless Cellular Gateway. And so this was a recent addition to the portfolio, and so we're going to be able to go into a great deal of detail about this platform and what it can do to give you the ability to position LTE radios at unique locations in the network. So the LTE modules for the ISR 4000 series. First, we have the NIM-LTE module. It comes in 4 different flavors, supporting different geographies as well as different service providers in the U.S. Those different versions may support various bands. They support various different microcode. So you need to make sure that when you're looking at buying this hardware, you buy one that's appropriate for the service provider and the geography that you're talking about. Category 4 is going to support up to 100 meg downstream on the platform. These are supported via a NIM slot, and that's on the ISR1000 platforms. And they do take a mini SIM size as a micro USB access for the diagnostics, and then a couple of antennas that we use for diversity antenna services. It's a single SIM in this particular piece of hardware and a single radio. So you can have a SIM associated with a single service provider and then a single radio that takes advantage of that SIM. It's based on Sierra Wireless MC7300 wireless modem, and then, as I said before, the firmware varies depending on what geography that we're talking about. Next, we have the Category 6 NIM, or the NIM-LTA. It's Category 6 with downstream speeds up to 300 megs. Again, we have SD-WAN support, dual SIM on this hardware so that we can have 2 different SIMs in the hardware so that if we have a failure on one service provider, the radio can switch over to an alternate service provider. And this comes in 2 different flavors, an EA and an LA. The EA supporting Europe, North America, and the Middle East with the associated bands that you see here, and then an LA version, the LA referring to Latin America, but it also supports Australia, China, Japan, India, South Korea, and along with the rest of Southeast Asia. Based on the MC7400 hardware from Sierra Wireless. Now, moving forward to the newer platforms, we have the LTE that we offer for the ISR1100 and the C8300 series. First off, I wanted to talk about what we have in the built-in platforms. And so there's some built-in Cat 4 and there's some built-in Cat 6. In the Category 4, on the ISR1109 platforms, there's 3 different versions we have, one for Verizon, one for AT&T and T-Mobile, and one for all of Europe. Europe sharing a common microcode that's used across the continent. And then those come with the associated frequency bands that those providers take advantage of in those geographies. For the Category 6 hardware, we have to go to the ISR 11.1 platforms, and the last digit can vary depending on if you want just Ethernet or if there's some DSL technology that you want to take advantage of. But they're LTE NA and LTE LA versions of that, which map back to PIM modules that are going to cover those same spaces. And then those modules these are for the built-in, and so the radio that's built in on the 1100 series will be Category 6, and then the antenna connections that you'll see here on the back of the 1100 router that we have here on the bottom, along with the GPS connector in the center of that platform as well. The LTE modem is integrated into the router. It's not modular. For all of these built-in solutions, it is a dual micro SIM with a single radio. So again, 2 SIMs, single radio, so only one connection at a time. And there is support for GPS for any sort of geofencing that you would want to do on the platforms. We do support that sort of behavior. We do have a USB dongle, the D-LTE hardware, that you can use to attach to some ISR1000 platforms. Not all of the 1100 platforms are supported. Detailed information on which platforms are supported is available on the data sheets on CCO. But this guy comes in 3 different flavors, one global, one for Southeast Asia, and then one for North America. Support for these modules in SD-WAN is on the roadmap. We don't have it just yet, but it is coming on the roadmap. And then you'll be able to take advantage of either adding this as a single radio or adding it as a secondary radio on those platforms, either in standalone or with SD-WAN. Maximum downstream bandwidth for this guy is 75 megabits. It's a single SIM on this guy, so single SIM, single radio. Based on Sierra Wireless WP7600 modems, firmware is going to vary based on what geography that you have. We do not have GPS support on this particular hardware, which makes sense because, without having these in a secure location, someone could pop out one of these guys and walk with it. So GPS didn't make quite as much sense to have on these platforms. Now, what I want to move forward to is the PIM hardware, which is our current and most modern form factor that we have for LTE radios on the platforms. The first one that we have here is a Category 4 offering, the P-LTE, and this comes in the 3 flavors that I mentioned before with the Verizon, US, and a global version for Europe. And so this maps back to the Category 4 radio that we had built into the platforms. This is basically a modularized version of the Category 4 radio that we had built into the 1109 platform. It is supported across all the 1100 routers, so any 1100 router with a PIM slot or any C8300 platform with a PIM slot would accommodate this module. 150 megs downstream bandwidth that we have on the platform with GPS support. We'll move forward to Category 6. So now you've moved up to from 150 megs downstream to 300 megs downstream. Support for SD-WAN available today. Dual micro SIM, so dual SIM, single radio. All of our offerings are a single radio. And then this guy comes in the 2 flavors, the EA and the LA, depending on if you're in Europe, North America, the Middle East, or using the LA version for Latin America or Asia. But the best offering that we have to date is this Category 18 device, which gives you up to 1.2 gigabits worth of downstream bandwidth available. And so this P-LTEAP18, or the way to decode that is P for PIM, LTE Advanced Pro, Category 18-GL, it's a global PID. So there's a single PID for this particular piece of hardware. You load different firmwares depending on what geography and what service provider you're attaching to. But the fact that we have just this single piece of radio hardware makes it much easier to choose and to have portability between different service providers. It's based on a Tenant wireless radio, and it supports a tremendous number of bands, but the ones that I wanted to point out in particular are the band 14, which is support for dedicated use by emergency services in the use case I talked about earlier, and support for band 48, which is that CBRS or that unlicensed spectrum support that we have on this particular module. This module is supported in the ISR 1120 and the 1160 series, as well as the C8300 platforms that we just recently announced. It does have 4 antennas. You can get by with just 2, although we recommend that you do use 4 for the best signal quality. And we do have access to micro USB for the debugs. There is no GPS support on this hardware, and frankly, the reason that we don't have the GPS support here is we basically ran out of real estate on the back of the module. It's hard to fit 4 antennas on there as it is, and to add a GPS connector would have been very, very tough. So that's why you don't see that GPS available here on this hardware. We do support the Category 18, but we do fall back to 4G or 3G as necessary, dual SIM, single radio, and we use the Tenant LM960A18 wireless modem in this platform, and that firmware is going to vary based on geography. And here's just a nice slide for the different platforms that this particular piece of hardware is supported on for the ISR 1000 platforms. It's supported across all of the Catalyst 8300 platforms. Now, I do want to talk in particular about the Cellular Gateway platform. And so this is the most recent addition that we've had to the LTE portfolio from the Enterprise Routing BU. And it's a very flexible but simple platform that gives you a great deal of power. And so what this platform is a device that has an LTE radio. So we have dual SIM with a single radio in this platform, and an Ethernet interface that we use to attach it to a client device. And so a lot of times your network stack is buried somewhere deep inside your building. It's in the basement. It's in a wiring closet surrounded by a bunch of concrete and a bunch of metal or a bunch of other wires, and you're not going to get the greatest LTE signal there. And it's expensive to extend your LTE antennas to the top of the building, or it may just be, frankly, just too far to extend those antennas to get the signal that you need. but you want to be able to take advantage of the low cost and the fast connection speeds for LTE as another means of connectivity. So what this device allows you to do is position this device somewhere in your building where you have solid and good LTE signal, in front of a window, along a ceiling somewhere, and then instead of having to have coax connectivity back to your network stack, you can take advantage of the Ethernet infrastructure within your building. You can run a direct cable from this device back to your router, whether that's an SD-WAN or a traditional router, or you can attach it to the switching infrastructure in your building so that the traffic can make it from this device back to your router. It can be powered either via a power brick, a wall wart, or by PoE. But what will happen on this device is that it will acquire an IP address from the service provider, and then in turn offer that IP address to the client device that's attached to it via DHCP. So the only thing that your client device has to have in order to take advantage of this cellular gateway is a DHCP client. And basically every networking device out there has a DHCP client. And then there's a secure shell access to get into the CLI to do configuration on the platform. And then you basically have the ability to extend your LTE radio to get solid signal quality anywhere in your building, take advantage of an existing infrastructure to connect back to your network stack, and you've instantly been able to add another means of connectivity either for redundancy or for active-active to your network with basically little to no effort. The platform is very secure by design, and we have trustworthy solutions, hardware to verify that the hardware hasn't been tampered with, the software hasn't been tampered with, all the things that you would expect from any of the complex routing or switching platforms we also have in this cellular gateway. And then we do offer the out-of-band management via a console port. You can secure shell into the platform for configuration ability as well. And then in 17.4 software release that we have just around the corner, you're going to see management there for this device via vManage as well. So in addition to managing as an independent standalone device, you'll be able to get detailed management for these on scale with zero-touch deployment via vManage. So for what we have on the hardware, 4 antennas on the platform. There's a 2.5 gigabit Ethernet downlink to the host. And so that 2.5 gig link is where we accept the PoE power for the platform. And we support that mGig so that we can support the bandwidth up to the full 1.2 gigabit per second that Category 18 offers on the platform. There are space for 2 micro SIM cards so that you can switch between service providers. And then, of course, a serial console, an optional USB, micro USB for debug, and a reset switch right there next to the SIM bay as well. You will see that there's an additional Ethernet port on the platform, and that's there for some future uses that we don't have enabled quite yet, but you may see some uses for that coming in the future. As I mentioned before, remotely deployed, Category 18, and we can fall back to Category 12 and Category 6 connections if Category 18 services aren't available to us. 4x4 MIMO antenna, taking advantage of all 4 of those antennas that are attached to the platform, and throughputs that match the Category 18 PIM that I mentioned before with 1.2 gigs down. We use that same Telet Wireless LM960A18 modem in this platform that we have in the PIM module that we can insert directly into the routing platform. So compatibility in that space as well. A single piece of hardware, it's a global piece of hardware, all the different frequency ranges that are supported. Initial software support for the platform comes in 17.3, and then 17.4 is going to give us the SD-WAN support for zero-touch deployment as well as management. But I do want to go back and emphasize that, again, that the only thing that you have to have on that client device is DHCP and SSH client for standalone deployments, and that's what we offer today in the 17.3. In the 17.4, we'll have the SD-WAN support. And in addition to that, there will be a web GUI in 17.4 that the Cellular Gateway is going to offer from itself so that you can log in and do GUI management for manageability, monitoring, as well as configuration for the platform. In the 17.3 software space, we have the ability for ISR1000, ISR1100, and the C8300 platforms, if they're attached to the cellular gateway, you have a web GUI that you can enable on the routing platform that gives you monitoring capabilities for the cellular gateway so that you can monitor signal strength, information about the cellular connection. So all that's available to you when attached to the Cisco ISR 4000, 1000, and 8300 platforms. And then if you're not attached to one of those platforms, you still have access to the CLI via SSH or the console port for management. And this is the slide here that goes through that in detail. We have the GUI management that's available on the listed hardware there. That's available in 17.3 for traditional and SD-WAN deployments. And then if you're attached to an ENCS platform, an ASR 1000, any other Cisco router, or a third-party device, you're missing that GUI management in the 17.3 software, but you still have full functionality via SSH. The configuration that's required on the client device is very simple. Basically, for IPv4 connections on your client device, if it's a Cisco router, you configure the IP MTU to match what you get from the service provider. You configure IP address DHCP. The configuration on your router is done to be compatible and to work with the cellular gateway device. If you want to add IPv6, all you have to do is turn on v6 routing, turn on IPv6 address auto-config default so that we insert a default route from IPv6, and that's all that you have to do. The MTU values may vary depending on what your service provider is, so you might have to tweak those a little bit because we do want to do the packet fragmentation back on the router if possible. That's the most efficient configuration. But these lines that you see here, either the 2 in the blue or the 4 in green, are all that's required to configure a router to take advantage of the cellular gateway hardware. So, the last question of the day, what are the 2 primary requirements to deploy the cellular gateway? And if the tool won't let you select 2, select at least one of the ones that applies. Because we did want to make the cellular gateway as compatible as we could across our hardware along with other vendors. We wanted to make it something that was easy to deploy and easy to use for almost everybody. Right, and almost everyone got that. So the DHCP client and the Secure Shell client are basically the only 2 requirements. You have to have the DHCP client so that we can accept the address that the cellular gateway negotiated from the service provider, and then the SSH client so that we can log into the box and to do some configuration. The switching infrastructure we can take advantage of, but you don't have to. We can either be powered by PoE or by a power brick. You have the flexibility there. But there's no requirements associated with an NTP client or any sort of reverse path forwarding detection. So quickly, I just want to look at some of the antenna options. This is not a full menu of the antennas that we offer on the platforms. This is just sort of the basics, but I did want to talk about a few things that are out there in the offering. We have different connector types that we have across the different hardware. ISR 4000 NIMs tend to use the TNC connector that you see here on the bottom right-hand side. The newer hardware tends to use the SMA connector types. That's what we see on the PIM modules as well as the cellular gateway. And the primary reason we switched to those, they're smaller, they take up less real estate. We can cram more stuff into the back side of those PIM modules than we could with the TNC connectors. And then the integrated antennas we have in the ISR 1000 platform use the bigger TNC connectors as well. So by default, you get these paddle antennas that come with the platforms. Those are the first 2 that you see here. They're a basic dipole antenna, LT-ANT-M-D or ANT-M2-SMA. They're basically either a TNC or an SMA version of the antenna. They support basically all the frequency ranges that we have in the lower spectrums that we've traditionally associated with 4G. For the 5G platforms that are coming, you're going to see different antennas available for those spaces. And then moving beyond that, there are antennas that we offer that are supported for different types of environments. There's a ceiling mount antenna that we have. It's just a single antenna, but it's meant to mount on a ceiling to get good coverage in that sort of space. We also offer omnidirectional pole-mounted external antennas as well. And so that's the first one that you see here where you may, if you wanted to do a truly external mount with a coax extension, you could use these to do that. And then other offerings for external 4G antennas that are low profile, and then panel antennas so that you can do directional antennas with a directional beam. If you have a clear line of sight of a cellular antenna, but you might need higher gain, then you would want to use one of these multiband panel outdoor 4G antennas. We also have some offerings that give you multiple antenna leads within the same external housing. For example, the first antenna that you see here, we have multiple leads that come out of it, 2 LTE leads and a GPS lead, so that you can attach to the main and the diversity antenna, as well as attach to the GPS with a single mount that may go on top of an ATM or some sort of moving vehicle, that sort of thing, so that you don't have to do multiple antennas. So that was it. But what you didn't hear me talk about, and I do want to make a point to address, is what we have around the corner for 5G offerings. I talked about a lot of 4G offerings that we have in the current portfolio, and we talked a lot about 5G technology, but not quite yet to the 5G hardware. So what you will see in the future from us is in that PIM form factor that we have for the modules that go into the 1100s and the 8300s, you will see 5G technology show up in that PIM form factor. And so that's on the roadmap just around the corner. There'll be some things that you'll start to see in the coming year for that. That same goes for the Cellular gateway as well. In that same form factor that we talked about that we have for the Category 18 radio, you're going to see 5G start to show up in that same form factor as well to offer that very high-speed 5G connectivity that you can position to get a good signal in the building and then have that come back to your routing core very deeper inside your building in that same form factor. And so those are in production. They do exist, and so they're on the way. And so you can anticipate to see some things come in the future on those. So in conclusion, 5G LTE connectivity is evolving quickly. We hear about it all the time in commercials on TV. There's a lot of pent-up demand for these things, and we're going to be well-positioned with our hardware to be able to take advantage of those when they're offered. There's a torrent of new possibilities, whether it's in hardware, network design, software requirements for 5G, and so you want to be positioned so that you're able to take advantage of those as a client, as well as maybe can start to consider offering your own 5G LTE services in that space as well. Look at Wi-Fi 6 and make room so that it can be a good companion as millimeter wave 5G matures, so that you can take advantage of both technologies to get the best coverage for your devices as well as people that work on your network. And we're going to be well positioned in the enterprise networking group to allow the current and future networking solutions to utilize what 5G LTE makes possible. We want to be good partners and to be able to offer what you need in order to make good solutions and to be able to offer what you need in your networks. And so that was it for the presentation. I think that we're going to do some Q&A at this point, if I'm correct.
So David, I have sent you to the question, if you can have a look. It says so the Cellular gateway is basically the IP protocol repeater between the LTE and the Ethernet network sites, right?
Sure. So to go a little bit more in detail about the Cellular gateway, I hate to make it sound more simple than it is, but think of it as an LTE to Ethernet transceiver, because the Cellular gateway talks to the service provider. He acquires an IP address just like any other device would, and then in turn offers that IP address to the client device via DHCP. At that point, the Cellular gateway is a pass-through device. He doesn't do any NAT, he doesn't do any firewall, he doesn't do any routing. All he does at that point is take the Ethernet traffic coming from the client device using the IP address that was associated with the LTE connection, passes it from the Ethernet and puts it onto the LTE radio to talk to the service provider. So no routing functionality. We're looking at strictly the IP pass-through device functionality. So once we do the initial part of doing the address acquisition and offering it to the client, he pretty much stands back, gets out of the way, and just does the translation between LTE and Ethernet.
Thank you very much, David. So I have one more question that I would like to do, and if the audience you have more questions, please let us know. Otherwise, we are going to close down the session. So one of the questions is, will there be a file upgrade to 5G capabilities?
I think the question is it field upgradable to 5G,
Yep.
which the answer would be that it is not. The 5G version will be a different gateway, same box, same manageability, but just a different modem in there. So that's not field upgradable.
Right. Yeah. So just like Kevin said, the cellular gateways are not field upgradable. The unit would have to be replaced. Now, for the PIM modules, if you've installed a PIM module in one of the 8300 or 1100 routers directly, all that you would need to do to get to the 5G functionality would be to replace that PIM module. So your routing platform, all that stays the same, no upgrades required. All you would have to do would be to swap out that PIM, small piece of PIM hardware for that particular use case.
I think we are okay to close down the session. So if there's any other further questions that you would like to have, like even after this session, you can place that one on this Ask Me Anything event, which is going to have place till next Friday, November the 20th. And also remember that you can find any other further events like these ones on Twitter, on Facebook, LinkedIn, on YouTube, and even in the technical application for those customers and partners. And actually, if you're looking for further events like this one and you speak another language rather than English, remember that you can find training like this one in Portuguese, in Spanish, in Chinese, Japanese, Russian, and even French, which is the newest ones for this year. And also, if you're looking for further ITD training, don't forget to have a look to everything that Cisco Learning Network has. They cover all architectures and technology as well, and not only the Cisco certifications. Well, once again, thank you all for joining us today. Please help us to fulfill a survey. It will come out just once we close this session. It helps us to find out if this topic is working well, how are we doing, and what kind of topics and things you would like to see in further and upcoming events. Please help us out to share that one and complete it on. And thank you so much for all of you. Remember, you fill out that survey, you will be able actually to redeem a special discount in Cisco Press, a 35% discount. Well, thank you so much to all of the team. Thank you so much, David, Kevin, Gabriela, Corelli, and everyone who was here today. And thank you so much for the audience to make this possible. I wish you have a great day, and we'll see you next time.
Thank you, Hilda. Thanks, everyone, for joining.
Thank you.
Thank you, guys.